Welcome to yet another session on understanding calculus. We'll continue from where we left last time.
A lot of say lot of lot to the base 2, lot to the base 3, lot to the base 4, lot to the base 5, and of x. Now what does this mean? That means first you have x, you take its logarithm to the base 5, so you will get some value. Now that value you take logarithm to the base 4, you will get another value, and that value you take logarithm to the base 3, so you will get some other value, and that value you take logarithm to the base 2, and then that will be your output value. Now while taking all these loads, the one thing that you must remember is whether any of this value falls outside the domain, because if anything falls outside the, even if one of them fall outside the domain, you will run into trouble. So that means the entire set of functions or smaller functions within the function are concerned, none of them should create trouble, and all the things should be within the domain. So how do we solve this? So we start with the outermost. The outermost is log to the base 2. So if log to the base 2 has to be defined, then this part, log this much, has to be more than 0. It cannot be even equal to 0. That is easy to understand. So log to the base 3, log to the base 4, log to the base 5 of x has to be more than 0. This is very easy to understand. Now for this to be more than 0, this part, log 4, suppose if you take the meaning of log, that means this part log to the base 4, log to the base 5 of x, so this will become 3 raised to 0. So because it is more than 1, this will become 3 raised to 0, right? So if you consider this, then 3 raised to 0 and log 4 to the base 4, log 5 to the base 5 of x should be more than 3 raised to 0, and 3 raised to 0 is 1. So this value should be more than 1. Now again similarly, you can write this as 4 is to 1. So this value, log 5 to the base, should be more than 4 is to 1. So 4 is to 1 or 4. And then that means that x has to be more than 5 raised to the power 4. So the domain should be such that x is more than 5 raised to the power 4. That means if 5 raised to square is 25, so 5 raised to 4 will become 625. So x has to be more than 625, otherwise the function will not be defined. Now as long as you have 2, 3, 4, 5, that means all these numbers greater than 1, the inequality will hold. But suppose if anything was say 1 upon 2 or 1 upon 3 or 1 upon 4, then the inequality will change. That is one thing that you should remember. So when you thought of this log, this is more than 0. So if you take this, then this is more than 3 raised to 0. But instead of 3, if this was 1 upon 3, then this sign will change. So it will become 1 upon 3, and then this will become less than 0. So if it is less than 0, then it will become less than 1. And when you write less than 1, you have to write that it is more than 0. So it has to be more than between 0 and 1. Whereas here it does not matter, because obviously if it is more than 1, it has to be more than 0 also. But if it is less than 0, then you have to specifically mention that it is more than 0 and less than 1. Right? Then we talk of this 1 upon 1 plus cos x. Now cos x, only thing is the cos x can vary between -1 to 1. So if it is -1, then this will create trouble. The domain will become 0. Otherwise, for whatever value of x you use, there will be no problem. So only thing is cos x cannot be -1, and -1 will be when cos is 2n plus 1 pi. So cos of cos x will be -1 when x is equal to 2n plus 1 pi. So all real values except this, where n belongs to integer. Suppose if you have this 1 upon 2 minus cos 3x. Now if it was 3 cos 2x, then this will become -3 to +3. But if it is within the cos sign, that means cos of 3x, then it does not matter whether you have 3 or 5 or 100 or 1000. the value of this cos of 3x will also vary between -1 to +1. But instead, if it was 3 cos x, then it will be -1 to +1. If it was 5 cos x, then it will be -5 to +5. But if it is cos 3x, then it will still remain as -1 to +1. Now here, since this is -1 to +1, the value of the denominator, if this is -1, this will become +3, and if it is +1, it will become 2 minus 1, so it will become 1. So the denominator will vary between these two extremes. So this will become 3 and this will become 1. So the denominator will always vary only between 1 and 3. So denominator will never touch 0, and hence the domain will be the entire set of real values.
Now we come to finding the domain of inverse trigonometric functions. Now for sine inverse and cos inverse, the domain is, the range is from -1 to 1, both included, from -1 to 1 inclusive of both. For tan inverse and cot inverse, the domain is the entire set of real numbers, and for sec inverse and cosec inverse, the domain is a set of real numbers without the values from -1 to 1. That means these are to be excluded. Now we'll work out a few examples. For example, this cos inverse of 2 upon 2 plus sin x. Now whenever you want to find cos inverse and the domain, then what you have to do is you have to see that this lies between -1 to 1. So what you write down is -1 to upon 2 plus sin x is less than or equal to 1. Then you multiply this on both the sides. So -2 minus, sorry, this is sin x. So -2 minus sin x is less than or equal to 2, which is less than or equal to 2 plus sin x. Now solving first this part. So minus sin x is less than or equal to 4. Now sin x varies between -1 and 1. So minus sin x would also vary between +1 and -1. So between 1 and -1, so it will always be less than 4. So irrespective of whatever be the value of x, this will always hold true. So this will be satisfied for all values of x. Now we come to the other side, this part. Now for 2 less than or equal to 2 plus sin x, 2 will cancel out and 0 will be less than or equal to sin x, or sin x will be more than or equal to 0. Now if you study the sine graph, now this is 0, this is pi, this is 2 pi, 3 pi, minus pi, and so on. Now sin x has to be more than or equal to 0. So it will be more than 0 over here. So between 0 and pi. Then here it will be negative. Then again from 2 pi to 3 pi it will be positive. Then here it will be negative. Then 4 pi to 5 pi. So that means all even pi to odd pi it is positive. Even pi to odd pi. Then 4 pi to 5 pi. And the same thing on the other side. So sin x will be positive only from between even pi and odd pi. So 2n pi to 2n plus 1 pi. So this would be the domain of x. So when the x lies between this, sin x will be more than 0, and hence that would be the domain of this. Then coming to the next one, cos inverse of 2x plus 3. Again you write -1 less than or equal to 2x plus 3, which is less than or equal to 1. So suppose if you subtract -3 from both the sides, so -4 less than or equal to 2x will be less than or equal to minus 2, and then divide by 2, so minus 2. So x will lie anywhere between minus 2 and minus 1, both inclusive. So that is the answer. Then the next one, so sine inverse of log 2x. So again here also log x to the base 2 should be between minus 1 and 1. Now considering this, now minus 1 has to be less than or equal to log x to the base 2. So suppose if you can also write this as log x to the base 2 is more than or equal to minus 1, and hence x will be more than or equal to 2 raised to minus 1, and 2 raised to minus 1 is half. So this is or half. So x has to be more than half, more than or equal to half. Then considering the other side, log of x to the base 2 is more than 1. So x has to be less than or equal to 2 raised to 1 or 2. So that means x should lie anywhere from half to 2, both the things inclusive. Tan inverse. I had said a little while earlier that the domain of tan and cot is the entire set of real values. So whatever be the value of x, it will be it will produce real values. So the domain of this function is the entire set of real values. Then coset of 3x plus 5. Now this is interesting. Now coset does not include this particular interval minus 1 to 1. So what you do is you find the interval minus 1 to 1 and then disallow that. That means what you do is you take first minus 1 and 3x plus 5 less than 1. Then subtract in minus 5 from both the sides. So minus 6 less than 3x less than minus 4. And then you divide both the sides by 3. So this will become minus 2 less than x less than minus 4 upon 3. So x lies anywhere from minus 2 to minus 4 by 3. But what you want is that x should not lie over here, and hence it is the entire set of real values minus both this minus 2 to 4 by 3, and here as we saw these are open brackets, so this will be open brackets. So values between these are not allowed, the extremes are allowed. So that is the domain for this function. And last is your when you have a greatest integer function, so sine inverse of the greatest integer function of x. Now you know the graph of the greatest integer function. Now if this is 0, this is 1, this is 2, this is minus 1, minus 2. So you will have here, then here, and then, so this is a graph of the greatest integer function. Now you want your output of this to be between minus 1 and 1. So your output should be anywhere between here and here. You do not want this output. So that means x values that you will be including would be from this, this and this. So this will be from minus 1 to here. This will be included because you want the output between this. So the output of this will be the input for sinus. Output of this greatest integer function would be the input for the sine inverse function. So the output of the greatest integer function should be between minus 1 and 1. So it will be from minus 1 to 0 plus 0 to 1 and even this one. So 1 to less than 2, because even if it is 1.9, the output will be 1, which will be accepted by the sine inverse. But if it is 2, then the output would be 2 and that would not be accepted by the sine inverse function. So as long as it is up to say 1.9 or 1.99, anything less than 2, the GIF would produce 1 and which will be accepted by the sine inverse function. So the value, the domain for x would be from minus 1 to till 2, minus 1 into that and 2 not included. So we have had a good session on practice problems to find the domain. I hope you like this lecture. We'll continue next time with more problems. So subscribe to the channel, like and share with your friends. Thank you.